For selecting multiple items without replacement, then we can deploy the combinations formula to help us quickly count, or at least more quickly count, the number of outcomes in the sample space and the number of good outcomes, as well as subtracting any overlap if the events are not mutually exclusive. So in the first example, we want to know what's the probability of drawing 2 kings or 2 tens from a standard deck. Now, whether I get the king of diamonds and the king of hearts, or the king of hearts and the king of diamonds, the order doesn't matter. I end up with the same 2 cards, so that's why we can use combinations in this circumstance. So in my denominator, I've got the sample space. So I have a total in my standard deck of 52 cards, and I'm choosing 2 cards. I want to end up with 2 cards in my hand, and my options are to end up with kings or tens, but I'm only picking 2 cards. So my denominator is 52, choosing 2. In the numerator, I've got to count up all the ways I can get the 2 kings, or, so that means I'm going to add all the ways that I can get the 2 tens. So for the 2 kings, we know that there are 4 kings in the deck, of which we're going to choose 2, or I've got 4 tens in the deck, of which I'm going to choose 2. So I've got a couple of these same expressions in the numerator. So we can start to set up our factorial expressions. So for the 4 choosing 2, remember that's 4 factorial, so n factorial on the top, over n minus r, so 4 minus 2 is 2 factorial, times r factorial, so another 2 factorial. And so we've got essentially 2 of those, since we've got the tens and then we've got the kings. In the denominator, we've got 52 factorial over 52 minus 2 is 50 factorial, and then times that extra r factorial, so times the extra 2 factorial. So we've got a lot of cross-canceling reducing that we're going to be able to do here. Now, one trick that we do have is we can see that we've got a 2 factorial in all 3 of our denominators. So if you imagine factoring out a 1 over 2 factorial from the top, and we've got the 2 factorial on the bottom, so we can cross-cancel all of those. Think of it as 2 over x plus 2 over x over 4 over x. I'd be able to factor out a 1 over x from the denominators here, and then that would be able to reduce with the x that's here. So that's the principle that we're using to do some reducing there. So then that leaves us with a couple of 4 factorials over 2 factorials. So 4 factorial over 2 factorial means I've got 4 times 3 times 2 on the top, over just 2, so the 2's are going to cancel out. And so that's going to leave me with just 4 times 3. So I'm going to have another one of those, another 4 times 3, since I've got the same thing happening in the second part of the numerator. And then down on the bottom with 52 factorial over 50 factorial, that simplifies to just 52 times 51. So ultimately where we're headed here, before we start reducing any farther, we'll go ahead and add these two 12s in the top together. So we've got 24 over 52 times 51. So now we've got some reducing. So 24, I can divide that by 4. So I get 6 over 13. And then the 6 and the 51 I can reduce by dividing by 3 on the top and the bottom. So I get 2 over 17. And so now my final result is 2 over 13 times 17, which is 221. So my probability in this case is 2 over 221. In the second example here, we're again drawing 2 cards from the deck. We want to end up with 2 face cards or 2 spades. So our denominator is going to be the same, 52 choosing 2. I'm only selecting 2 cards from the deck. It's just I want to end up with either 2 face cards or I want to end up with 2 spades. So for the 2 face cards, again, that's jacks and queens and kings. And so I've got 4 of each of those. So I've got a group of 12 cards from which I'm choosing 2 of them. Or we want to end up with 2 spades. So recall we've got 13 of each suit, so there are 13 spades in the deck. We want to choose 2. But unlike the previous problem with the kings and the tens where there was no overlap between those, now we do have an overlap. There are spade face cards. And so as we counted all the ways that we could get the 2 face cards, included in that was the possibility that we could get a couple of spades. So we have to subtract that overlap. And so the total overlap is going to be, how many spade face cards are there? Well, there's a spade for Jack, Queen, and King. So I've got 3 spade face cards, and I'm going to be picking 2 cards. So here's where I'm subtracting my outcomes, where I end up with both 2 face cards, and they happen to both be spades. So we can set up our factorial expressions. So the bottom, just like it was on the top, we've got 52 factorial over 50 factorial times 2 factorial. Same setup. For each of these others, so for the 12 choosing 2, I've got 12 factorial over 10 factorial times 2 factorial, so n minus r factorial, and then another r factorial. I've got a 13 factorial over 11 factorial times 2 factorial, and then I'm going to subtract that overlap. So I've got a 3 factorial on the top over 3 minus 2 is 1 factorial, and then the extra r factorial, 2 factorial. So just like we saw in the previous example, all of my denominators have a 2 factorial in them, so I can go ahead and wipe all those out. So now I've got 12 factorial over 10 factorial on the top, so that's 12 times 11, plus 13 factorial over 11 factorial gives me 13 times 12, and then minus 3 factorial over 1 factorial, it's just going to be 3 times 2, and then that's all over 52 over 50 factorial. I get 52 times 51. So in the numerator, we've got 132, 12 times 11, plus 156, 13 times 12, minus 6, for a total of 282 over, and I'm going to leave it as 52 times 51, so we can more easily do a little reducing. I can divide the top and bottom by 2, so we've got 26 and 141. I can divide 141 by 3. I can see that that's divisible by 3. So that's 47, and 51 divided by 3 is 17. And so since that 47 is prime up top, I know I'm done. So I've got 47 over, and then 26 times 17 is 442. The same approach using combinations can be applied to bags of marbles like we see here. So we want to know what's the probability of drawing 2 green marbles from a bag of 4 green, 5 red, and 6 blue. So again, we're grabbing 2 marbles out of a bag that has 15. 4 plus 5 plus 6 is 15. So our denominator is going to be 15 choosing 2. And then in our numerator, we want to grab 2 green. So we've got 4 green marbles. We're going to be choosing 2. And there's definitely no overlap that we have to concern ourselves with here. So in the numerator, we've seen this expression before, 4 factorial over 2 factorial times 2 factorial. In the bottom, we've got 15 factorial over 13 factorial, 2 factorial. So I'm going to reduce the 2's in the top and the bottom. So up in the top here, 4 factorial over 2 factorial leaves me with 4 times 3. On the bottom, 15 over 13 factorials leaves me with 15 times 14. In the second example, we want to find the probability from the same bag of drawing no green marbles. We want neither of the marbles to be green. So we may be tempted to think, well, I just need the opposite of the probability we just found, so I would have 33 out of 35, but the mistake there would be that would be including scenarios where we have 1 green marble, which we don't want. So in this case, we're still from the same bag of 15 drawing 2. So we've got 15 choosing 2 in the denominator. And so the non-green marbles are here. So we've got 11 of those. So we want to draw just from that group of 11 because we want no greens in our selection. So the denominator is going to be the same here as it was just up above. So we've got 15 factorial over 13 factorial times 2 factorial. And then up in the numerator, it's now 11 factorial on the top over 11 minus 2 is 9 factorial and a 2 factorial. So I'm going to wipe out the 2's. Up in the top then, I end up with 11 factorial over 9 factorial, or 11 times 10. On the bottom, we've got 15 times 14. And so with our reducing here, we've got 10 and 15 gives us 2 and 3. And then we've got 2 and 14, so that gives us 1 and 7. And so our end result is 11 times 1 on the top is 11 over 3 times 7, 21. So clearly not just the opposite of what we got above, because in between these two probabilities are the scenarios that would include at least one green marble.